So in lesson 13, natural logarithms, you should have learned about the natural log and the transcendental number e, which is used in exponential models. So it's just a number. It's really, really, really long and doesn't stop. So they gave it a special name. It's just called e. It probably got its name because it's used in a lot of exponential equations. Kind of like pi got a special name because it's a special number used for circles. That's you can think of e as kind of like pi. But e we use in exponential equations, and it is the inverse of the natural log. Right? So natural log is just log the base of e. It gets a special, because it has a special number as its base, it gets a special name. And because e is a natural number found in science with population increase, anything that has to do with exponential growth, it just seems that this number is the best for some reason to model that growth. And so it's just kind of a natural thing found in science, that's the number. So we call the log with base e the natural log. So when solving logarithmic equations using exponents, you saw that we had to write the log first as one logarithm. It couldn't be two things. So that's what you're doing here for 1, 2, and 3. That's what you'll have to do in order to solve equations using ln. So if this was 8x and it was equal to 7 or something like that, I would need to combine these two logs first before I was able to use e as its inverse to isolate x. So what I mean by that is I'm just going to use the rules of logarithms, just like every other log, they still apply. So instead of ln 16 minus ln of 8, I can rewrite that as ln of 16 divided by 8. And so that simplifies to the ln of 2. And so that's what you're going to be doing with 2 and 3. That would be my answer. That's one logarithm. 2 and 3 use the laws of logarithm to write the expression as a single logarithm. Please show your work. And so now number 4, that kind of expands on what we were just doing in 1, 2, and 3. Now we're actually going to solve for x. So first, like we did in 1, 2, and 3, we have to write this log as a single logarithm. So I need ln of something. We can use the rules of logarithms. Since this 4 is out front, we can rewrite this as ln x squared equals -2. And so I'm going to take e to the ln of x squared, or sorry, x to the 4th. What am I thinking? Sorry about that. So ln of x to the 4th equals e to the -2. E to the ln is going to, that's going to be the inverse, so it's going to just give me 1, and then I have x to the 4th. And that's going to equal e to the -2. And then what I can do is I can 4th root both sides of the equation, and that's going to give me x equals e to the -2. You can rewrite that and simplify that in multiple ways. The directions do ask you to round your answer to the nearest hundredth. So once you get to this point, once you get to x equals, you can put that into your calculator and find the exact answer for x. And in 7, 8, 9, and 10, you're going to be doing kind of the same thing, but now you're going the other way. Now you're using the natural log to solve for x. So we have e to the x equals 15 here. E is by itself, so I can take the ln of e to the x equals the ln of 15. Now this works because if you think about your rules for logarithms, this x can get written down in front, ln times e, or the natural log of e is just going to be 1. So x times 1 is just x. And then on the right side we have the ln of 15. And again, you can just substitute that into your calculator and find the exact answer rounded to the nearest hundredth. For number 8, 4e to the x equals 10. Make sure that you isolate e first. So we need to divide both sides by 4. So I have e to the x equals 10 over 4. Now I can take the natural log of both sides. So that's just to help you start on number 8. And then for 10, 12, and 13, it's just showing you a practical problem, real world equation that might be used. So you're going to use this equation here. You want to find how many days, t days, it takes to use the given amount of power. So 10 watts, that's my power. So I'm going to put 10 in for P, set that equal to 50 e to the t over 25. And now I'm going to do exactly what I did 7 through 10. So if I divide both sides by 50, I'll get 1/5 equals e to the t over 25. Then I'm going to take the natural log of both sides. So I got ln of 1 over 5 is equal to t over 25. Now I'm going to multiply both sides by 25, and I get t equals 25 times the natural log of 1/5. Now once I have t equals something, I can put that in my calculator and find the exact number of days it takes to use 10 watts.